comparability of sets. You observe these two sets. A is equal to A, B, C, D, E, F. B is equal to A, B, C, E, I, O, U. U, X, Y, Z, P. How many elements are there? In A, there are 6 elements. How many elements are there in B? There are 11 elements. Well, if you ask a small kid of a 7th class or 8th class, which set is bigger, then that child definitely says that this is bigger. Well, my dear, what is the concept behind it? Is there any big set or small set? If at all a comparison between two sets is required, there is a condition. Unless A is a subset of B or B is a subset of A, you can never compare the two sets. This set is small set, absolutely wrong. This set is big set, it is also absolutely wrong. You cannot compare these two sets at all. You cannot say this is smaller or this is bigger. You cannot say. Why? Because for the comparability of sets, we should have either A subset of B or B subset of A. Then only we can compare the two sets. These two sets are not comparable. Not comparable, isn't it? Well, let us now have the perfect definition of the word comparability. Two sets A and B are said to be comparable. Said to be comparable if and only if A subset of B or B subset of A, one of them should happen. Unless or otherwise, it is just not possible to compare them. In such a case, that is, if A is not a subset of B and B is not a subset of A, then A and B are just incomparable. They are not comparable. When can you compare those two sets? When can you say that those two sets are comparable? Either A is a subset of B or B is a subset of A must happen. Then only comparability of sets happens. Well, if A and B are two equal sets, then automatically they are comparable. Both A subset of B and B subset of A. Isn't it? Yes, that is about comparability. The next concept that we may have to learn is power set of a set. Power set. What do you mean by power set? As an example, consider A is equal to 1, 2, 3. How many subsets of A are there? You gather 5 is a subset of A, and these are the subset with just one element, and these are the subsets with just two elements, and this is the only subset with all the elements. You gather all of these. What do you say about this set? Set of all subsets of A. Set of all subsets of A is of course called power set of A. It must be denoted by this symbol. That is, you may have to use the script capital P, not the just capital letter of first case letters. No, script capital letter P of A. And you may feel that it is time taking to have with a design like this. Then you can have this P of A. Is of course the power set of A. Is of course the power set of A. Well, it is a special case of interest to look at the number of elements in the power set of A. By the by, how can you define the power set of A? The set of all possible subsets of A. The set of all possible subsets of A is power set of A. Is an example. It appears on the board. Good. How many elements are there in power set of A? To answer it, we may have to learn the number of subsets of A. Yes. Now, We shall learn that. If A is equal to x1, x2, x3, etc., xn, set containing n distinct elements, then number of subsets of A is, you can imagine, number of subsets with 0 elements is only 1. What is that? 5. What is the number of subsets with 0 elements? NC0. As there are n elements, NC0 subsets with 0 elements. How many subsets are there with 1 element? NC1. How many subsets are there with 2 elements? NC2. How many subsets are there with 3 elements? NC3. Like that, how many subsets are there with all n elements? NCn. Hence, the total number of subsets of A is NC0 plus NC1 plus NC2 plus etc. NCn. Of course, it is 2 to the power of n. 2 to the power of n. From the knowledge of permutations and combinations and binomial theorem, we know that the sum of all these binomial coefficients is 2 to the power of n. Yes. That is why the total number of subsets of A is 2 power n. If A contains n elements, number of subsets is 2 power n. If A contains 3 elements, number of subsets is 2 cube, 8. If A is a set with 4 elements, what is the number of subsets of A? 2 to the power of 4, 16. If A is a set with 5 elements, what is the number of subsets of A? 2 to the power of 5, 32, like that. Good. From this, we can say one thing. If n of A is equal to n, then n of P of A 2 power n. N of P of A is 2 to the power of n. That's good. There are some more points to be discussed with this. The number of subsets we shall now discuss. If A is a finite set with n elements, then the number of subsets of A is 2 power n. The number of non-empty subsets of A is 2 power n minus 1. Why should you put minus 1? Non-empty. So, from the collection of all subsets, empty set has to be deleted. Hence, the total number of subsets becomes 2 to the power of n minus 1. Good. The number of proper subsets of A is 2 power n minus 1. Why should you get minus 1 here? What do you mean by a proper subset? That subset which is different from A, isn't it? And in the collection of all subsets, A will also be there, you know. You delete that A, therefore it is 2 to the power of n minus 1. And next, the number of non-empty proper subsets of A is 2 power n minus 2. These are the conclusions that can be drawn immediately from the set of subsets, the number of subsets, if A is a set with n elements. Okay, that's it about this number of subsets. Next. The next heading that we may have to learn is a universal set. What is meant by universal set? It's very simple. A superset of all the sets under consideration is called a universal set. For example, A is equal to A, B, C. B is equal to B, D, E. C is equal to A, E, I, O, U. You consider this set S is equal to A, B, C, D, E, F, I, O, P, Q, U, Z. Observe these sets. A is a subset of S, B is a subset of S, C is a subset of S. So, you pronounce these sentences in reverse order. S is a superset of A, S is a superset of B, S is a superset of C, hence S is a superset of, S is a superset of, S is a superset of every set under consideration. This C is a universal set. That is a universal set. Well done. Suppose I omit P from this set. Can you call this set as a universal set? Why not? A is a subset, B is a subset of S, C is a subset of S. I omit Q also. Can you say now it is a universal set? Why not? It is again a universal set. And I like to delete Z. Can you say? Yes, it is again universal set. So, universal set is not unique. And it depends on the way in which we define. That is why in the definition itself, it will be told a superset of all these sets under consideration is called a universal set. A universal set. That's it. So, let us try to write the sentence also. What is the sentence? A superset of all these sets under consideration is called a universal set. That is the definition of the word universal set. And there are so many symbols to represent it. And more familiarly, we use the symbol mu to stand for the universal set.